It happened. Vercel actually shipped. I feel like it's been a while since Vercel dropped a bunch of things at once, like many years by now. The last two Next.js confs were relatively low in terms of new features, both for Next and for Vercel. That changed today. They dropped a ton of things I've been personally waiting for forever. From a new pricing model, to queues, to a way to run code that's sandboxed from your users, to even handling captchas properly. It's kind of nuts how much stuff they dropped that I've needed for a while. It almost feels like they've been looking through my Twitter and hitting all the checkboxes for all the things that I've been bothered by recently. That all said, Vercel has not paid me for a long time. In fact, quite the opposite. I spend a lot of money paying them nowadays, especially with the success of T3 chat. So someone's got to cover today's bill, and if I'm going to be honest, it can't be them. So quick word from today's sponsor, and then we'll dive right into what I think about everything Vercel just shipped. One of the biggest changes I'm seeing from AI is the willingness of big enterprise companies to adopt tools by small teams and companies themselves. It's kind of crazy to see that small businesses like my own with T3 Chat are getting interest from much, much bigger enterprises. There's one big thing that's hard to get right, though: auth. And no, AI is not going to solve this problem for you. Setting up auth in a way that these big businesses are willing to use and adopt and integrate in their systems is something that I wouldn't wish on my worst enemy. And that's why I'm so pumped about today's sponsor, WorkOS. These guys made it way easier to get your application and, most importantly, your authentication ready for enterprise adoption. You can take my word for it, or you can look at the absurd number of companies that you're already using software from that have made the move themselves. From Cursor to OpenAI to Vercel to Carta to Vanta to so many more. I always smile a bit when I open up the Cursor dashboard and see the WorkOS AuthKit sign-in. It's cool to know that they're using the same tools we use every single day. I've personally chatted with Guillermo about auth platforms like WorkOS, and he told me really early on that he regretted not adopting one earlier. I think we could have done even more business if we had partnered with WorkOS earlier. It's been incredibly well received. I couldn't agree more. They found an incredible balance of making something enterprise ready for these IT teams to integrate and something that's actually nice to use for us as full stack TypeScript developers. It's awesome that they found this balance, and we're seeing more and more people adopt it for that reason. If you're tired of thinking about auth and are ready to just ship, check out WorkOS today at soydev.link/WorkOS. Let's dive in. I'm going to do a real quick overview of the things that they changed so that we can keep ourselves on track. The one that I'm personally most excited about is the active CPU billing. It's going to be a real fun one to talk about, and specifically why it matters. They added the sandboxing for code runs, specifically for user-submitted code, or more importantly, AI-generated code. Queues, finally. And then their CAPTCHA killer solution that is actually looking very compelling. It seems like they learned all the right lessons from the things I've been complaining about with CAPTCHAs. If you haven't watched my CAPTCHA video already, obviously I'm biased because I made it, but I think it's one of the best videos I ever did. So check it out if you haven't. It's very practical, applicable information on how to set up CAPTCHAs and rate limiting in your services properly. They also officially dropped the AI gateway, which is their alternative to something like OpenRouter. Actually looks pretty compelling. We'll dive into that too. So let's start with the active CPU billing, because I am so excited about this. Again, I'm biased because this is going to save me a ton of money. To understand this, we need to understand how servers are built. If I have one server, I don't know, let's say that this server costs us $10 a month. This server is just one server. If it gets no users, or it gets 1,000 users, or it gets 1,000,000 users, we have our fixed rate. It's $10 a month. But what happens if this server can only have, 500 users concurrently at its peak? Then you need to spin up more servers. Maybe you need to keep them live for the whole month, or maybe you're dynamically spinning them up and down. You end up in the wonderful Kubernetes hell that we've all seen and I've often made fun of, as you need to spin up more servers and remember to spin them down and wait for them to spin up and possibly lose traffic in that time. Not fun. And that's why the world started moving towards a serverless model, especially for the short-term compute needs that most web apps have, because most users are making a bunch of requests, or sometimes just one request doing a lot of DB, and then not doing anything for a while. And the idea of serverless isn't you don't have servers. Obviously, your code runs on a server. The point is that the actual server setup that you have, the amount of provisioned servers you have running, is directly reflective of the number of users currently making requests. So previously, the way the world worked is you had your one server and all of your requests went to this. So you had a bunch of different requests from all sorts of different users hitting the same server, taking however long they need to take, and then sending the responses on the other end out to the users on the other side. But if you ever needed more requests than this could fit, that was when you ran into problems. You'd have to either manually spin up a server and hold these requests until it was ready, or do something else. Serverless had the goal of flipping this dynamic entirely. So instead of being $10 a month for a server, it's billed on gigabyte hours is the usual phrasing for it. So gigabyte hour is how many gigabytes of RAM over how many hours is the thing that you'd be billed on. So now each of these requests, instead of having its own server, they each have their own separate instance that is alive for as long as the request needs it to be and then dies immediately after. And if each of these requests takes a very small amount of time to resolve, like 100 to 200 milliseconds just to get the DB requests done, generate the HTML, and send it to the user, this makes a ton of sense. So if you think of this, like each of these takes 100 ms, let me shrink it like that, then this model makes a ton of sense. And since more and more compute has been working this way, I say as somebody who built a lot of things like this model actually was really, really good for web applications and like CRUD apps and e-commerce and all those types of things, because you never have to worry about having enough servers for your users, and the users are making such short requests that if you add all of these millisecond times up, it's still not going to cost you a whole bunch of money. So it ends up being often a good bit cheaper than if you provisioned a big enough server, because you don't have to keep the server provisioned during downtime and you're just paying for the time spent requesting. So what's the problem? Well, let's say like these 4 requests are people requesting their user data, like their email address that they use to sign up or their chat history on T3 chat. Those all happen really quickly. That's all good. But what happens when you start generating a response from OpenAI? This stops being 100 milliseconds and starts being 20 seconds. Now imagine you have a bunch of users doing this constantly. Now you're not adding up 100 milliseconds times 4, you're adding up 20 seconds. And suddenly having an individual server running for each of these requests sucks, because there's a second dimension we have to be considerate of. We were to put these two axes. Axis 1 is duration. This is how long does the request take to run. And axis 2 is intensity, like how much CPU is actually being used during this request. So for something like your Next.js app, it's not using a whole lot of CPU when it's making a DB request, but it uses a decent bit when it's turning that JSON into HTML to send to the user. Or if you're doing something like image encoding, where you're re-encoding a PNG into an AVIF or something like that, like we're adding for T3 chat for partial image gens, those things take a good bit of CPU. And that means that you're limited with how many things you can do on a server. If you have 10 users re-encoding images on a server, that's way more compute than even like 1,000 users who are just waiting for a DB response to come in. So making sure that you're paying attention to the actual CPU usage relative to the duration is key. This is where different workloads get interesting though. Something like rendering your Next.js app is, I would say, medium usage, low duration. So SSR, medium usage, low duration. Something like image re-encoding. Image encoding is high usage, medium duration. And this is the interesting thing. There's this area in the corner here of like high duration, low usage that has been a really rare thing. So there hasn't been much innovation in this corner for a while because there hasn't been a need to. The goal historically has been, how do we reduce the duration of our requests? Almost all the work that companies like Vercel have put in, that all these database companies have put in, they're focused on how do we shift down the duration chain so that things can happen faster, so users have a faster and better experience on the web. The problem is there's this new workload that fits really well in this corner that I've been hinting at a bit. LLM generation requests. And to be clear, I am not saying the actual running of the model to take in an input and create the new tokens that you send to the user. What I'm referring to is the endpoint that takes the user's request, attaches whatever metadata, whatever memory or whatever else, and then sends that to the OpenAI API with the services API key, and then receives that stream and then streams it down to the user. That ends up being really high duration and extraordinarily low CPU costs. And that ratio is very strange. It is not something that most of these services were built for, except for one, Cloudflare. Cloudflare's infra, specifically the Cloudflare Worker product, has really low CPU performance. If you take a given like server rendered task and run it on Vercel or on Lambda with Node and then run the same exact code on workers, it will take 2 to 4 times longer to actually give you a response if it's the CPU that you're measuring. So if you take some JSON and convert it to HTML with React and Next.js, that'll take 4 times longer on Cloudflare because the CPUs are weaker and their virtualization layer is different. Versus on Vercel or Lambda or even a traditional server where you have some dedicated CPU allocation and a real kernel running real Linux, running real Node on top of it, that ends up being significantly faster. And also with something like Lambda, you can up the provisioning so it has more compute when it needs it. This is where things get interesting because Cloudflare's infra has historically been bad for SSR workloads, but it's been really good for what I referred to as the world's most advanced switch statement. If you're effectively using Cloudflare as a way to resolve a request and point it in the right direction and do basic changes to it, Cloudflare's been really good. And one of the things that makes Cloudflare's model so special is their net CPU billing. So let's redraw this here. Because remember, there's 2 numbers we care about. There is the duration and there is the actual CPU usage. So let's say a user is making a request for their metadata. User requests their metadata. This request will probably be pretty fast. 100 milliseconds if your database is fast enough. This request probably isn't going to need to do too much in terms of CPU. If we were to measure this by the amount of CPU utilized, and we'll just measure it in milliseconds as well to make it easy. Let's say it was 10 milliseconds net CPU. So if we shrink this accordingly, it ends up looking like that. Actually quite a bit less if we make this to scale. I'll do that instead. There we go. You get the idea. A request from a user that takes 100 milliseconds of wall clock, if it's spending most of that time waiting for the DB, it's not going to use much CPU. To expand this, literally, to make it a little clearer, red is when we're being billed, hollow is when we're not because something else is happening. So that little red section in here, we are requesting from DB. That takes a very small amount of time. Then we wait for, 85 milliseconds, wait for DB response. And at the end here, we have a little more compute to take that DB response, re-encode it in JSON or whatever format you want it to, and then send it to the user. So in this 100 millisecond clock time, we're probably doing at most 15 milliseconds of CPU actually running. If you were inside this box and you looked at how much CPU utilization it was using, you'd see it at around 100%, then less than 5%, probably 1 to 0, depending on how much other stuff's going on in the box, then back up to 100% for a brief moment, then the data goes down to the user. The thing that made fluid compute really cool, which was Vercel's way of parallelizing things on a given Lambda that I've covered a bunch in the past, is that it could effectively stuff other people's requests in when this happened. So here, since this CPU is not doing anything, it will stuff in another user's request. It'll use some CPU, do the thing. And then when this one's being waited to resolve, we can have another one and another one. And now what we're being billed on is the wall clock for this whole window. So let's say that this ends up being 150 milliseconds of total compute. So now we squeezed 400 millisecond requests into a 150 millisecond window. So you're not going to be billed for 400 milliseconds. You're going to be billed for 150. That's really cool. You know what would be way cooler? Remember how we said that each of these totals to 15? Let's even round up a bit. Let's say each of these is 10. So it's 20 milliseconds of compute and it's 150 milliseconds total. So 20, 40, 60, 80. If we take all of these, remember each of them is about 10. You'll see this is quite a bit shorter than what we ended up paying for. It's way less than half. Actually, I think in this case, it's a bit over half technically. The point being that happens because there's a lot of dead areas in this. We have here where nothing happened. I'll use blue to show those dead areas. We have here to here where nothing happened. We have another dead zone there as well. These dead areas you're still paying for because you have to have the server spun up waiting for these requests to be completed. When you're looking at something like a 100 millisecond request to go get something from the database, this looks pretty bad. If we're a little more realistic with server rendered loads, instead of this user requesting their metadata, they're requesting their user page. That might need a little more CPU in the end. So change it to 150 milliseconds, and at the end, say it needs a lot more compute after it gets the response from the database to actually render the page. Something like this would benefit a lot more from the model that Vercel had with fluid compute. because such a high percentage of the time is still spent doing real work that it's fine. But what about the thing we were talking about before? These dreadful 20-second to sometimes like 8-minute long requests? How much compute do you guys think those are using? So let's take a 20-second wall clock generation. We have this initial block at the start that is verifying the user and their data. So we verify the user, we send the request off to OpenAI or whatever other API, and then we are waiting, and we keep waiting, and we keep waiting. And then eventually near the end, we get the full response, and we send that down to the user. Maybe we persist it in our database. Or let's say we are sending back the tokens as we get them, which is very common. Each of those takes literally like 2 cycles of CPU. So we have a ton of these super, super like impossibly thin lines randomly throughout where a tiny, tiny bit of CPU is used. And on this 20-second wall clock, not only are we not using seconds of CPU, not only are we not using milliseconds, usually a AI LLM generation call can be measured in nanoseconds of CPU used. So something even as crazy as a 20-second wall clock time could be as low as 100 nanoseconds of compute. That's the problem. That ratio is insane. If you look at how much compute is used relative to the amount of time the request took, that's where this pricing gets really rough. That is the original pricing. Because now I have this 20-second runtime I am paying for, even though I'm using almost no CPU during most of it. And my honest guess is that when more and more of these AI workloads started appearing on Vercel, their average CPU like usage and like the percentage that their CPUs were utilized during requests probably went from like 60 to 80% down to less than 5%. And when I look at our CPU utilization for our box, especially if we turn off Fluid, the CPU utilization is so close to zero, it's funny because you have to just sit there kind of when you're waiting for the response. If you do the thing I showed earlier with Fluid and you force a lot of things into that same Lambda request, it helps, but it doesn't help enough because, again, Cloudflare bills on net CPU. So they are only charging you for these red boxes. They are only charging you when the CPU is going. And they could do that because they don't have to spin up a new kernel for every dev. If you are a dev deploying on Vercel and I'm a dev deploying on Vercel, we both have our own code, we both deploy. Even with Fluid, when it's sharing the node to do multiple things at once, it only shares across a given user and a given binary of code. So your code can't run on my Lambda when my Lambda is running. On Cloudflare, the abstraction isn't at like the kernel or Firecracker or Lambda level. The abstraction is higher. It's in V8, the actual engine. They built the worker isolate layer, which allows them to have basically the event loop being shared. So if you know the JavaScript event loop, like requests are made, functions get queued up and executed, and data like flows through it like that. The way Cloudflare works is effectively when you don't have anything on your event loop, when you don't have anything queued ready to go, someone else has a request for their own code running on the same instance. That's what was so powerful about Cloudflare stuff is their event system means your code can be running and doing nothing and cost them nothing because that same V8 instance can be resolving other people's requests with their own separate code at the same time. There's like 4 options here. You have traditional servers, you have serverless where it's 1 instance per request, so 1 instance per user effectively. You have Fluid Compute, the serverless servers things that Vercel did, where you have 1 node that can resolve multiple users' requests, but only has 1 binary, like 1 piece of code running on it. And then you have the Cloudflare solution, which is lots of different developers' codes running on the same box at the same time. And it's abstracting on like the per function call level. And when I tell you the price is massively different, I mean it. As we see here, Cloudflare bills on the CPU time, the net CPU cost, the amount of time the CPU is actually invocating. And they charge 2 cents per million CPU milliseconds. And they bill it in milliseconds because that's like how much these requests take. It's measured in nanoseconds and milliseconds, not seconds and minutes like it is on other platforms because they're charging based on that. There's a max of 5 minutes of CPU time per invocation, but that's CPU time. The actual request doesn't have a duration limit. So it could take 2 days to resolve, and it's fine as long as it's not doing anything with the CPU in that time. Really cool. And Vercel finally decided to match that. And this is exciting to me because I've actually argued with them a bunch about this because I compared our numbers on Fluid to our numbers on serverless to my friends' numbers on Cloudflare with workers, and there was a pretty rough gap there in terms of the cost. Like I know people who were doing more inference than us that had bills that were like 100th of hours for compute, because it doesn't matter how many thousands of requests you can stuff into a 30-second window if the alternative is being charged for 1 millisecond per request instead. I can't go into details of these numbers because the ones I know are very much under NDAs, but I can tell you it is as much as 100x difference. And it's pretty easy to see that difference if you just think through the diagram here. If I have requests that take 80 seconds, and one of these 80-second requests uses, I'll even go higher than normal, 5 milliseconds of CPU. Best case, we could squeeze like 100 things into a fluid compute instance. So worst case with serverless, if we have 100 requests that match this, so we'll say 100 requests, 80 seconds, 5 milliseconds of CPU. If we have a normal server, we're just paying the server cost. That's hard to measure. If we do serverless, then we're paying that 80 seconds times 100 equals 8,000 seconds. That's rough. Fluid, let's say we squeeze them all in and it all fits. So it's 80 seconds times 1 because we're only invocating once. That's 80 seconds. Net CPU billing, 5 milliseconds times 100 equals 500 milliseconds, which is equal to 0.5 seconds. Is this a real number from a real dashboard right now? No. But I can tell you from my experience, this lines up. This is accurate to the things I've seen. The gap's insane because the amount of CPU used for these inference tasks is relatively low in comparison. Like the 80 to 5 millisecond ratio, this is the thing to pay attention to. A request that takes 80 seconds can use as little as 5 milliseconds of CPU. There is nothing you can do to make this number worth paying for. You have to find a way to charge this number instead if you want to compete with Cloudflare. And this is what Vercel just announced. They are now going to charge for this instead of this. And that's probably going to cost them a ton of money behind the scenes, depending on how they have it provisioned. I don't know the details of how they implemented this, because the reason Cloudflare can charge on this is during that 80 seconds, they can run someone else's code on the same node. On Vercel, they can't do that because it is running its own kernel, its own node instance. So if I'm not doing anything, they can't just spin someone else's code up on the same box or on the same instance. So let's read what they've done and how they did it. Introducing active CPU pricing. Of course, they had to come up with their own name for it. Fluid compute exists for a new class of workloads. I/O-bound backends like AI inference, agents, MCP servers, and anything that needs to scale instantly, but often remains idle between operations. This is the key. That scale instantly part is so useful, both for like surges in traffic, but also the other side where you're, spinning up a preview deployment when somebody files a PR. Having things that can instantaneously on demand spin up and down like that is so useful for all the different layers of my stack. These workloads don't follow traditional quick request response patterns, which again, this is what Vercel has optimized for historically. How can we get the data close to the server? How can we format the data faster so there's less time being spent generating the right thing? How can we cache stuff to skip the compute layer entirely? What can we do to reduce the amount of time it takes to resolve a request? That's been Vercel's goal since day one. That does not work in the AI world. These are long-running, unpredictable workloads, and they use cloud resources in new ways. Fluid quickly became the default compute model on Vercel, helping teams cut costs by up to 85% through optimizations like in-function concurrency. Today, we're taking the efficiency and cost savings further with a new pricing model. You pay CPU rates only when your code is actively using CPU. Huge. From servers to serverless. In the early days of cloud compute, teams ran long-lived servers. You had to manage provisioning, handle scaling, yada, yada. You get the idea. Serverless changed that. It abstracted away infrastructure configuration and introduced automatic scaling. Each request triggered its own isolated instance, just as I said. So here we see it starts with a lot of compute, does nothing for a while, and then ends. And you're paying for that whole time. From serverless to fluid, here's the difference. Now you can squeeze them all into one fluid node. Didn't they say 85% before? Now it's saying up to 90%? From my experience, it's been 85 to 90, so it's funny those are the two numbers. I've seen both in our dashboards. And then from fluid to active CPU. Fluid improved performance and cost, but there was still room to optimize. Even with high concurrency, there could still be moments where all invocations are waiting on external resources and no code is actively running. During these idle periods, functions stay in memory, do no work, yet they're still incurring CPU cost. Again, if we look at this way, we just want to pay for the parts where the CPU is working. This aligns with actual usage. Compute costs scale with real work, not just with time a function is alive. So what's funny here is that something like our conversion of images is effectively free CPU cost-wise because we are already running the nodes, the CPU is being paid for, we might as well use it. This is going to make that feel much more expensive because we're actually paying for that compute now, where previously we effectively weren't. But that also means our bills are going to be way, way cheaper overall because most of our workloads aren't using CPU for the majority of the time. So the active CPU pricing model. Fluid Compute now charges based on 3 key metrics. Active CPUs, which reflects the compute time your code actively is executing on a virtual CPU. Measured in milliseconds, calculated as the number of vCPUs allocated, multiplied by the time that they're actively being used for. Starts at $0.128 per hour. So let's run the math here quick. You know how I am. I like to know the hard numbers. So Vercel is this per hour, which in milliseconds, 2 cents per million CPU milliseconds. This is going to be annoying math because these numbers are not compatible. That's definitely intentional on both parties. Okay, so how many milliseconds are in an hour? Okay, hour, minute, second times 1,000. Okay, so that's 3.6 million milliseconds. So that's 3.6 times more. Is it going to be exact? It's going to be 0.02 times 3.6. No, it's a bit more. Okay. So Cloudflare is charging 7.2 cents per hour of compute. I'm just going to get rid of the other Cloudflare number because I think billing in hours is a little more sensical. Cool. So Cloudflare is still cheaper per hour, but it's not that big a gap. It's a bit under 50% difference. There is also a bill per invocation, though. So we will get to that in a second because I believe Vercel has it as well. They also have to charge for provision memory, which covers the memory required to keep a function alive while it's running. It's measured in gigabyte hours and billed at a much lower rate, less than 10% of active CPU, thanks to Fluid's ability to reuse memory across multiple concurrent invocations. Starts at 1 cent per gigabyte hour. Cloudflare doesn't charge for this. So to be fair, Cloudflare has a much stricter limit on memory. Yeah, workers are very limited in how big they can be. The amount of JS it can run is 10 megabytes of actual binary, which sounds like a lot for JavaScript, but it's not, especially for server-side stuff at scale. Each worker can use up to 128 megabytes of memory. That's very low, relatively speaking. If you architect around that and you're not using Node APIs and things heavily, it's fine, but that's not much memory. That said, that's 128 megs of memory per request, where on Vercel, you have the amount of RAM that your node has across all the requests being routed to that node. So it depends on what your memory characteristics look like. But I am going to skip that section simply because the way memory works in these platforms is so different that it's not really comparable. But they say it's less than 10%. So we'll add another 10% to the Vercel bill accordingly. This is CPU cost, memory, Vercel 10% of CPU cost. In Cloudflare, we'll say free. And then we have the request costs because invocations are charged for on these platforms. They say for Vercel that like in traditional serverless, they are still billing for this. It remains part of the overall billing. 60 cents per million requests. Next section for request cost. Vercel is 60 per 1 mil requests. Cloudflare does charge for this 30 cents per additional million. So if we go through and compare these numbers, I would guesstimate that it averages out to Vercel being, worst case, about 2x more expensive. And that sounds terrible just upfront, saying switch from Vercel to Cloudflare and cut your costs in half. I'm going to drop a number that I probably shouldn't. The ratio of our Gemini bill to our Vercel bill right now, and this is before all these changes were made, it's 1 to 40. Our Gemini bill is 40 times higher than our Vercel compute bill. If you add all of our other inference, it's closer to 1/80th. And this is fluid compute costs. It's a massive gap. So again, because these workloads tend to be expensive, but not just for the compute, for all these other things, that gap doesn't matter as much as it seems. Like a 2x here might feel really big. It is not, because remember when I said it was like 100x difference on net CPU to not? Let's say it's the same gap here. We'll say it's 50x. What's going to happen for us is, again, if we look at the Gemini bill, it's going to be a 50x difference. Our bill is now going to be 1/400th of our, not Gemini bill, of our inference bill. I would expect after these changes are implemented and we can run it, that our inference bill for actually paying Gemini, OpenAI, and everybody else will be 400 times higher than our compute bill. And if we switch to Cloudflare, it could be as good as 800 times, but we would be giving up node compatibility. We'd be giving up things like image compression on the same server. We'd be giving up a bunch of the convenience around how we deploy, how we run things on Vercel, how we manage domains, and how we do all these other things. It's a decent difference there, especially when you consider how much higher the RAM limitations are, how much faster the compute is, and all these other things. The argument is no longer you use Vercel until it's too expensive, then you move to Cloudflare. Now it's, is the benefits of Vercel worth a roughly 2x gap to you? There are benefits and negatives to all of this. They're both very compelling options now. And the Vercel doesn't make sense at a certain scale thing is kind of killed by this. Vercel's platform now is close enough to costs as long as this is implemented as generously as they have implied through their posting. The cost gap here is nowhere near as bad as it used to be. It is comically less bad. I saw some speculation about how Vercel uses middleware and edge stuff. They did actually formally kill edge workers in middleware today. You still have the middleware file, it just runs on Vercel's compute engine instead. They did briefly play around with the worker D model from Cloudflare as like the thing that would run on the edge, but it had its benefits and negatives, as most things do. And they slowly moved off of it. Yet they're managing to replicate the awesome billing characteristics of that model inside of more traditional compute engines, which is really cool. A different way to think about this is you're paying around a 2x premium for way faster CPU and actual node compat. This isn't even including the developer experience wins. This isn't even including the cool things the Vercel platform does, all the other stuff. You're effectively paying 2x more for your CPU to run faster, for node compatibility, and yes, for DX stuff that I think is valuable and really nice. Previously, this was closer to a 100x difference, so that's a nice change. Cool. Next is sandboxing for code. This is a really fun one. And funny enough, Cloudflare also announced their solution for this. Well, they announced that the thing that they just dropped is their solution for it. So sandboxing for code. Run untrusted code with Vercel Sandbox. Vercel Sandbox is a secure cloud resource powered by Fluid Compute. It's designed to run untrusted code, like code generated by AI agents, in isolated and ephemeral environments. It's a standalone SDK that can be executed from any environment, including non-Vercel platforms. That's actually really cool. So if you're running on Cloudflare or you're running on, I don't know, Heroku or traditional AWS, and you need to just spin up some sandbox that is safe and isolated and won't screw up other things on your platform to run some generated code or user submitted code. This is like funny. I see chat already dropping eval. Yeah, it's like if eval was safe, which is really cool. Also, don't get me started on Cloudflare's node compatibility. The progress they made is awesome. It's not real node. Do they support certain node APIs in a compatible enough thing? Cool. But if you need node, if you need something like, I don't know, FFmpeg or something that actually uses native code on the platform, Cloudflare can't do that at all. And don't get me fucking started on trying to run Sharp through WASM on Cloudflare. Remember that 10 megabyte limit? FFmpeg WASM on Cloudflare? No, that is not a thing. People have claimed they have done it. I have never gotten anybody to share code that actually works for it. It's all fucking made up. You cannot run actual workloads on Cloudflare that do things more complex than executing JavaScript. You cannot do it. Don't pretend you can. I'm tired of people pretending you can. You can't. They even know that. That's why they put out containers. Exactly. They have containers. They are not cheap. They are good. It's awesome that they have containers now to solve this problem. But I am so tired of people pretending, oh, you can just WASM it and then Cloudflare can do everything. No, it fucking can't. Anyways, untrusted code. They have an SDK for it, the Vercel Sandbox. It's really cool that they're integrating this at like an SDK level where you can create a sandbox, hand it a path or a buffer with code. Here we're taking this generated text, we are creating a buffer from it, and then running a command in that sandbox. Command node arg script.js, tell it where to pass the standard out and standard error. That's really cool. This is really cool. Here's the docs for the sandbox so you can see the type of stuff you have control of for it. In this code below, you'll set up a sandbox with 4 virtual CPUs that uses Node 22 runtime and will do all of the following. Clones the GitHub repo for a next app, installs the deps, runs the next server, listens on port 3000, open it, sandbox domain in a browser, and stream logs to your terminal. Sandbox will stop after the timeout of 5 minutes that we set. Cool. Source, this is the source that we want it to pull from. Type git. Resource, vCPUs 4. You could also probably set memory and stuff like that there. Timeout, milliseconds, 5 minutes. This is their fancy helper for converting a string to milliseconds. So 5 minutes is for 300,000 milliseconds. Cool. Ports, 3000 to open that port. Runtime node 22. We then run commands. We run the npm install command, std and std out to pass it. Install.exit code is not 0. That means it failed. We log that it failed. Process.exit. Starting the dev server, sandbox.run command, npm run dev, same deal, detached to true. Set a timeout. Spawn, open, sandbox.domain 3000. Cool. That's actually really nice. Good stuff. There's a ton of potential in the sandbox platform. I'm excited. As I mentioned earlier, Cloudflare just announced their way to run Docker images and containers on Cloudflare. And it seems like today they rushed out this blog post on how to use code sandboxes with that. That looks similar. That's kind of funny that we got at Vercel/sandbox and at Cloudflare/sandbox within 3 hours of each other. Kind of funny. The race between Cloudflare and Vercel has never been so tight. These guys are tooth and nail fighting each other constantly now. And that's awesome because we are the ones who benefit the most at the end. The reason Vercel got so much cheaper is Cloudflare. The reason Cloudflare got containers is Vercel. The reason Vercel has sandboxes now is Anthropic. And the reason Cloudflare does is also Anthropic, to be fair. But yeah, like we are all moving forward now because these two platforms are competing so actively that we get better stuff. And of course, as I hinted at before, Anthropic also today dropped their similar thing. Build and share AI-powered apps with Claude. They added the ability to build, host, and share interactive AI-powered apps directly in the Claude app. Theirs is like a higher level thing where you can share a Claude chat and the artifact in it that is generated can be its own like mini app that you share with other people. Cool. Built on top of similar things. I wouldn't be surprised if they were actually using Cloudflare's solution here, or maybe even Vercel's. Probably Cloudflare's though, knowing them. There are other platforms that already did this. I know Daytona decently well. We're considering using them both for T3 chat and also talking about potential sponsor in the future. Just full disclosure, I might work with them later. There are a lot of these types of solutions where you can call the Daytona SDK, create an instance for a given language, hand it some source code, in this case, code run, console log hello world, and then it can exec it, give you the response. This is a space that I expect to see getting more and more interesting over time because the need for these types of tools to make it easy to safely execute code are more and more valuable because AI can't really interact with the real world, but it can absolutely write code that does. So expect more of these things to start happening, and also for platforms like Vercel and Cloudflare to start pushing them more heavily. Being able to sandbox the space where your code runs in order for code that you don't trust to be able to run is going to be more important now than ever. And honestly, I'm slightly betting on Cloudflare for this one because they're deep in the zero trust world. It's a huge part of their product and platform. So the idea of running untrusted code is something that I think fits them very well. You can also tell this blog post was rushed out because they didn't even put a space here. They did on the others. But it's very clear this was an announcement they were probably working on already, but they rushed out this post in order to stay on top of Vercel's announcements. So that's sandboxing. Next, we have queues. In queues, I'm actually really excited about. Funny enough, it's one of the things I think Netlify was really ahead on. Huge fans of what Netlify was focused on here because it's important work, especially for like long run generation tasks that don't have partial steps. Like if you're doing an image gen or deep research or something that just takes a long time to go, having compute running for that whole time sucks. On Cloudflare, since you're only built for the net CPU and it can run for an effectively infinite duration, it wasn't too big a deal. You can just spin up a thing and let it sit and wait for a while. But we're actually having problems right now where certain models like a O3 Pro can take so long to run. We don't have O3 Pro and T3 chat as a thing any user can just use. You have to bring your own API key because it's so expensive. The problem that we've seen is that for a handful of users, it times out. And it's timing out because our functions only run for 800 seconds. That's just the value that we have hard-coded on them. We can bump it higher, and I think the new fluid compute changes mean we can bump it even higher. But if the request takes 15 minutes to resolve and we don't have enough duration for that, that sucks. It'd be a lot nicer if we could queue up an action, and then when it is done, run the code to persist it and show the user the result. Queues are really helpful for these workloads that have to wait for a long time and to do literally nothing. So you don't even need to deal with the memory allocation in that time. This is a limited beta, to be fair. This is one of the earlier products, which after some of the experiences I've had with Vercel scares me. Some of these early products are fully fleshed out and ready to go. Others aren't at all. I usually try to gut feel it with them. And also I look at what other customers are moving over before I make my own decisions here. But here's what they have to say. It's a message queue service built for Vercel applications in limited beta. Lets you offload work by sending tasks to a queue where they'll be processed in the background. So users don't have to wait for slow operations to finish during a request, and your app can handle retries and failures more reliably. It's kind of like temporal, which is crash-proof code. It lets you create workflows around all of the code that you write. So if some part fails, you can rerun it. It's like an infra-level effect type thing. And there's also ingest. I tried working with in the past. Seemingly really good product. Not the easiest to interact with, but very promising stuff. Really good DX. Not very type safe initially. They might have finally fixed that, but it wasn't at the time. But these are durable workflow and durable workload platforms. And it seems like Vercel's decided that they're not worth investing in anymore. They want to make their own instead, which I fully understand. Those companies are weird. And now they're building their own thing instead. Oh, Trigger. I forgot about Trigger. They're actually awesome. I need to stop forgetting about Trigger.dev. These guys are really, really good. And they're awesome to interact with too. So again, this is a thing a lot of other places had implemented, but Vercel now has on platform. They even have these fancy dashboards where you can see how long each part takes. And obviously they're leaning into AI, transcribe to video, transcribe audio, all those types of things. Generate content, runs, it has steps, it creates the text, it then creates an image and returns the result. You can retry it, you can trace it, you can do all sorts of different things with it. Also a good use case for stuff like crons. You get the idea. Queues and like workflow and workload durability solutions are important. It's cool seeing them building them into Vercel directly. Under the hood, Vercel Queues uses an append-only log to store messages and ensure tasks such as AI video processing, sending emails, or updating external services are persisted and never lost. Key features: PubSub. So it's topic-based messaging allowing for multiple consumer groups. Streaming support. Handle payloads without loading them entirely into memory. Ooh, that's very interesting, actually. Streamlined auth, which is annoying to set up right. Cool that they did that. And a TypeScript SDK with full type safety. I think Trigger has that. None of the rest do. That's a really cool thing. Send and receive are from Vercel/queue. Send topic, message, receive topic, consumer m.message. Awesome. I do not know how they made this type safe. I would want to see how this stuff is defined so that we know what m's shape is there. But yeah, it's early access. So you have to sign up for Vercel community and express interest in order to see more. Yeah, cool stuff. I want to see a lot more before I highly recommend it. Until then, I would personally recommend Trigger, but all the options are pretty good. So that is Queues. Next is another one that feels tailor-made for me. Their CAPTCHA killer. I'm not going to say my previous CAPTCHA video is an essential watch, but I think it's a pretty damn good watch. If you haven't, definitely check it out. If you appreciate content like that, hit that sub button. Less than half of you have. It costs you nothing. Mine as well, right? Anyways, the CAPTCHA killer product I've been told about for a bit. By the time they were hitting me up to try it, though, I'd already made the move to HCAPTCHA and was really happy. That said, none of the major CAPTCHA solutions, those being Turnstile, reCAPTCHA, and HCAPTCHA, none of them even have an NPM package, much less like a modern full-stack TypeScript-y dev experience. They all expect you to embed a random script in your page and manage all of the data and loading states and everything yourself, the partial states for invisible versus visible, and all of that. The things that I want out of a CAPTCHA specifically are the following. I want a good invisible mode where most people will never see the CAPTCHA or even know one is running. I want low false positives, meaning I don't want a lot of users getting failed. I ideally don't want any users being failed when they are real users or real humans on a real browser. I want good DX. Specifically, I want an NPM package that knows what React is. And don't get me started on the random open source packages for something like reCAPTCHA, because they're all entirely unmaintained and garbage. I want type safety, different error states handled. And I guess this is kind of DX, but it's also just a general desire. Promotion to visible CAPTCHA on fail. This is a big deal. HCAPTCHA is a thing for this. They call it 99.9% passive, which means for most users, most of the time, they'll never see a CAPTCHA. But if they fail to validate them before it passes the token to you, then they will pop up a CAPTCHA challenge for the user for them to pass and then give you the new token that's generated from that instead. If I want to do that with reCAPTCHA, I have to myself run the invisible CAPTCHA, validate that separately, and if the validation fails, send that state back down to the client to tell the user's device, hey, you failed our CAPTCHA check. Can you try it again, but with a visible CAPTCHA? So I have to manage all of those partial states, all of the piping back and forth, and also keep myself from accidentally building something that is really useful for bots to test against. And that's the worst part, is it's very easy if you implement your own like progressive CAPTCHA layer where it promotes, or I guess demotes you from invisible to visible. You might have just accidentally created a system where people can test their CAPTCHA workaround bots. Not fun in the slightest. Not fun at all. I wouldn't wish this shit on my worst enemy. I've been through it with CAPTCHAs. I'm done. So let's see how Vercel's stacks up. Introducing Bot ID, invisible bot filtering for critical routes. Modern sophisticated bots don't look like bots. They execute JS, solve CAPTCHAs, and navigate interfaces like real users. Tools like Playwright and Puppeteer can script human-like behavior from page load to form submission. Traditional defenses like checking headers or rate limits aren't enough. Bots that blend in by design are hard to detect and expensive to ignore. Just to emphasize the point here, HCAPTCHA pricing, $1 per 1,000 verifications. BrightData's HCAPTCHA solver at the highest tier, $0.05 per 1,000 solves. You pay 5 cents more per 1,000 to work around an HCAPTCHA than I as the developer pay to serve you one, which is really funny when you think about it. So yeah, take that as you will. Having something that's more resilient is cool. That said, depends on how expensive each request is. If a request by a bot sneaks through, how much value are they getting and how much money does it cost you? If they're getting less than $1.05 per 1,000 requests of value working around your CAPTCHAs, then it doesn't matter. But if they are, you might need something more strict. This is where Bot ID comes in. It's a new layer of protection. Think of it as an invisible CAPTCHA to stop browser automation before it reaches your backend. It's built to protect critical routes where automated abuse has real cost, like checkouts, logins, signups, APIs, or actions that trigger expensive backend operations like LLM-powered endpoints. And this is so much nicer. Check bot ID, isBot equals await check bot ID. If isBot, deny. No configure tuning required. Install a package, set up rewrites, mount the client, and verify requests server side. I want to see what the setup rewrites part does. Let's read through how this works first. Bot ID is available in 2 modes, basic and deep analysis, which adds advanced detection checks. Detection starts at the session level. Bot ID injects lightweight, obfuscated code into the requester's environment that evolves on every load and is designed to resist replay, tampering, and static analysis. It runs invisibly with no CAPTCHAs or changes to the user experience. This is funny because the previous examples they had were like, verify with Vercel, and they had a little thing that would appear in the UI, and I explained why I hate that, and I'm assuming others did, because it doesn't seem like there's any UI at all with this. That is cool. Unlike traditional defenses, Bot ID doesn't rely on static signals like user agent headers or IP ranges, which are easy to fake and become outdated. It also avoids more intrusive methods like CAPTCHAs, heuristics, and reputation scores, which can frustrate or block real users. Instead, Bot ID counters the most advanced bots by silently collecting thousands of signals, mutating detection logs on every load to prevent reverse engineering and making spoofing difficult, feeding attack patterns into global machine learning networks that continuously improve protections. Fast, reliable, built for devs, server-side verification, takes a single function call, yada yada, no API keys to manage, that's really nice. No score thresholds to tune, that is so nice. One of my favorite things about HCAPTCHA, you don't have to determine what is or isn't human yourself. There's a little chart on the reCAPTCHA dashboard that you can move left to right for how strict you want to be, because you have to give it a number between 0 and 1 for how strictly you want to filter out users. They recommend 0.7 to 0.8. We lost like 5+% of our requests if we went above 0.3, which meant that we were almost certainly letting in some bots, which sucks, but reCAPTCHA was not fun. Deep analysis powered by Casada. This is the partner that they worked with. Again, Vercel is not hesitant to pull in a third party where it makes sense, even if that third party doesn't know how to do layouts on small screens. That is funny. Anyways, they are the like core platform for the automated threat detection stuff. Supposedly they're really good. From what I've seen, they are not easy to set up, and you're expected to sign a pretty crazy deal with them because they don't even show pricing. Yeah, they really want you to sign like a deal with them, not just like go and sign up yourself on the site, which is cool that Vercel is the one that's going to take the hit here for us, make that partnership, and then give it to us at a reasonable rate that's much more transparent. No separate service sign up for, just install the package to find the routes you want it on and deploy. Enterprise grade defenses, they've been using it for things like V0 for a while. Cool. Design for teams with targeted automation that slips past conventional defenses. Available now for all teams. I want to see how they are handling the rewrite bit, because that was very interesting to me. Okay, we have to wrap our next config with bot ID. Oh, this is so that ad blockers won't break the script loads. This is similar to the workarounds I have to do for analytics and such. Or you can manually rewrite. Oh God, these are some URLs. These are going to start getting blocked on things. People are going to be pissed. I know how this back and forth goes with ad blocks. That'll be fun. Bot ID client, protected routes, API sensitive, checkout and sign up. And then we have their component that they provide from bot ID/client. You pass it the config with the routes that you want to protect. And now it knows to automatically add on any request to those routes the right header information so it can verify the user. Check bot ID on the routes configured in the bot ID client component. If you don't have the component or the protected route in the component, that will fail. Makes sense. The one thing that's annoying here is it doesn't seem to have the granular level of config for if you want to skip the verification on a paid user, but you want to do it on a free user. This doesn't have the right heuristics to enable that, which is a little annoying. I get why it doesn't, but it'd be nice if it did. And then in the route, you just call check bot ID. It will handle grabbing from the request and doing everything else it needs to. My hesitations here are that if you're not using Vercel, or more importantly, you're not using Next, this needs request data. So you'd have to pass it request, and it doesn't seem like they offer that. So this is a very tied to Vercel solution. Server actions, same deal. You just call check bot ID. Pricing. Here's where we are. Basic, all plans, free. Deep analysis for Pro and Enterprise costs $1 per 1,000 requests. Okay, interesting. So the basic check is always free for everyone. Huh. That makes this way more compelling, actually. Okay, I think I see what they're doing here. They show this off as two modes, but what this actually is two products. Basic is their turnstile killer, because Cloudflare doesn't charge for turnstile, at least not traditionally. They let you create a certain number of widgets, which are certain sites and configurations that a widget is allowed to be used on, and it doesn't charge based on how much usage it gets. So for free and cheap services that need to make sure that they're not getting abused, this freeness made turnstile a really compelling option for services that had a lot of use and made very little, if any, money from their users. But it also had an insane false positive rate, and especially in invisible mode. It was basically unusable in invisible mode. So you were either giving Cloudflare free branding and reach by showing the Cloudflare logo on the UI, or you had a 15% chance that a real user's request failed. Not worthwhile even for free. I found this to be rough. And then if you need more than 20 widgets or 15 host names, you have to be on an enterprise plan, which is contact sales pricing. So you know how that goes. There's a lot. Turnstile is quite possibly my least favorite Cloudflare product. I've played with most of them for something at this point, and Turnstile is the hardest by far for me to recommend. It supposedly got better after we tried, but it was so bad when we tried that I cannot in good faith recommend it unless you really need free. And now I still can't, because basic mode on Vercel's bot ID for all plans is free and integrates way better too. So this is a really compelling, Turnstile destroyed option. If this existed when we built the captcha system for T3 chat, we almost certainly would have used it. Deep analysis is meant to compete with reCAPTCHA and HCAPTCHA and more advanced solutions like what WorkOS is doing with Radar and whatnot. And this price of $1 per 1,000 requests is perfectly matched to HCAPTCHA and reCAPTCHA. They both cost pretty much exactly the same. This makes so much sense. For something like us, I could see us setting the basic tier for most routes and then the deep analysis tier for chat generation, for example. Yeah, this makes so much sense. Is there a place where you can turn on deep analysis at a code level? The bot ID has to be turned on basic or deep analysis at a project level. I hate that. Vercel, I know somebody's watching or will watch later. Fix that. Give me the ability in this config where I'm actually defining the routes here to pick if it is deep analysis or normal. I should be able to choose here. And then, of course, I'd have to specify when I call here, on the check bot ID call, I'd have to put deep : true or something. give me a big error if I have the wrong config on either side. But that's, I think, a relatively trivial change that will make this way more compelling, where for most routes I can use basic and the expensive ones I can use for that. Good stuff. That's a very compelling change. And another one of those things, like, I am so excited for a year or two from now where the pain I had to go through with captchas just feels archaic and wrong. The same way that like configuring a big Webpack config now just is funny because we've moved past that problem as an industry, but it was so real at the time. So this is one of the most compelling things they've done. I'm excited for a future where people don't have to think about and set up captchas like this anymore. Can't wait for us to get there. And if we go through this list, good invisible mode, they only have invisible mode. Low false positives, seems like it's really good according to the numbers I've seen from them and from the partner, Casada, right? Yeah, from their partner, it seemed really good. Good DX, looks the best DX I've seen so far by quite a bit. They're not handling the different error states the ways I would want to. I'm sure like you have to send the error back yourself and show it to the user. It'd be nice if they made it easier to handle those. I still want promotion to a visible captcha because there will always be some type of user that like really needs to have a visible captcha verification because they're on a weird browser on a weird OS with a VPN. I don't want to restrict those users, but I want them to put the work in. You get the idea. Oh, Resend just removed Cloudflare turnstile for their sign-in, and it's cleaner and their login is 2x faster. I'm almost positive that they just moved to the new thing that Vercel put out. I would be surprised if it wasn't that. Oh yeah, here we are. 6 hours ago, Vercel announced this new feature. They implemented it, same bot protections, testing, push to production. Not only does it declutter login, it cuts our login times in half. Huge. That's awesome. Good stuff. It makes the code so much simpler too. Yeah, if you've implemented reCAPTCHA 2 or even reCAPTCHA 3 before, you know how rough they can be to set up. This is super compelling. Arguably the most compelling thing that they launched for most developers of most services. Really cool. And now we are at the last thing Vercel dropped. The AI Gateway. They've been talking about this for a bit, but it officially shipped today in beta. So what is the AI Gateway? A single endpoint to access a wide range of AI models across providers with better uptime, faster responses, and no lock-in. Now in beta, you can use models from providers like OpenAI, xAI, Anthropic, Google, and more. You can do usage-based billing from the provider-listed prices, bring your own key, improved observability, including per-model usage, latency, and error metrics, simplified authentication, fallback, and provider routing for more reliable inference, really big deal, and the higher throughput and rate limits. The start of the hot takes. Anthropic is the worst way to use Anthropic models. What do I mean when I say this? There are a couple ways that a model provider can fail you. The ones that I care about the most are reliability. How often do requests succeed versus failing? How often does the service actually go down and just be unable to resolve entirely? How often does it error for random reasons? All those types of things. Like on a scale from planet scale to neon, where does it fall? And then the other really big one, rate limits. You have no idea how hard and obnoxious it is to get Anthropic to bump your rate limits, no matter how big a customer you are, no matter how many connections you have. None of those things matter. They have 4 tiers of customer that are defined by how much money you spend and you getting promoted internally to be a certain tier. Claude Sonnet 4 on the base tier can do maximum 50 requests per minute, which sounds like a decent bit until you realize it's 20K tokens per minute in and 8,000 tokens per minute out. One user's request can be up to 100,000 tokens in. So one user can saturate this for 5 minutes with one request. Actually entirely unusable for real workloads. So you need to bump up this tier list before you get somewhere usable. And even then, 80,000 token per minute maximum on tier 3. The tiers are, again, based on how much money you spend and when you get like the bump pressed. Tier 4 requires that you're spending 5,000 a month or more. And then you're like forced onto custom tiers where they might or might not bump these limits for you. So we had Claude 3.7 bumped relatively high because we were one of the bigger promoters of the model when it dropped. I did my YouTube video and everything, and I bugged them, and they gave us higher allocation. And then Sonnet 4 dropped, and we are at, obviously, tier 4. 200K tokens in, that is 2 requests per minute. Even if we can do 4,000 requests per minute, if our input token limit's 200K and 2 people hit 100K on 2 messages, that's 2 messages a minute. That's horrible. That's terrible. That's entirely unusable for us. We regularly blast through the tier 4 limits. And once it's custom, you need to get on an enterprise plan and do the sales dance back and forth and everything. It's hell, miserable. I wouldn't wish it on anybody. So what do? If the rate limits on Anthropic's API are this terrible and negotiating with them is horrible, and the other third point, this one really annoys me, cost negotiations. When you're doing a certain level of throughput on anything, you can usually negotiate down the rate and get a discount. If we committed with Anthropic to do 20K a month of committed spend, so we literally spend 20K a month for just credits. If we go over, we can spend more, but if we don't have that, we have committed to spending that much regardless, they'll give us a discount. The discount we would get if we agree to 20K a month, that is $240,000 a year, 5%. We get a 5% discount for agreeing to an absurd level of spend. So all of these things with Anthropic suck. The reliability is garbage, especially when new models drop, especially when Cursor ships new features. Rate limits make it literally unusable. And the cost negotiations are not a real benefit. The way that they would prevent the things I'm about to talk about is if they made the negotiations and the rates that you can get there way friendlier and easier to do. But they won't do that because they're kind of insane. And here is where the problems start. Reliability is rough. Okay, I can't find my screenshot, but I had screenshots of how bad the fail rate was on drop. When Claude 4 dropped, Opus had a 15% success rate from the official APIs. Sonnet was heavily rate limited, and Bedrock and Vertex were not supporting it yet. Wait, Bedrock and Vertex? Isn't this a Claude model? Yeah. One of the really fun things that Anthropic did is that they made a deal with both Google and AWS to allow them to host the models at the same rate that Anthropic does. So if you really want to keep your models inside of AWS or GCP, because that's where all your other spend is, you can go ahead and use Anthropic's models there. You just have to pay Google instead. And I'm sure Google gets some level of discount, but they are forced to charge the same rate so that they're not undercutting Anthropic as part of their deal. Makes a ton of sense. I get why they do that. But where things get interesting is when we look at reliability and rate limits. Do you know what's really reliable? Do you know what doesn't really care about rate limits? AWS. Do you know what's kind of reliable and is not really aware of what rate limits are except for on AI Studio, which is a whole separate rant for another time? Google Cloud. So what if we could use the best of all of these? What if we could use Anthropic models on Anthropic service when it's up, but when it's down, we could just take the same request and do it on Google's infrastructure or Amazon's infrastructure? This is what OpenRouter does. If we look for Claude Sonnet here, Claude 4, you can see they have a couple different providers. They actually, believe it or not, default to Google Vertex US because it's faster than Anthropic's APIs. It's almost twice as fast. Now I'm almost certainly going to move us to OpenRouter because we'll get a 2x speed improvement at the same cost and better reliability because when other things go down, it will just route to the right place. It's a really good platform. Since OpenRouter's already negotiated with all of these providers to get through the rate limits to the best of their ability, since they're spreading the traffic across all of these different providers, and they let you bring your own API key for the ones you want to, all of that together ends up making OpenRouter a really compelling platform for running Anthropic models. I can't recommend that you use the Anthropic API when you could use OpenRouter instead, because you'll, for the same price, get faster responses, way better reliability, and not have to worry about rate limits. That's a phenomenal deal. And if you bring your own key for Anthropic models and then the Anthropic API is down, you can have it configured to fall back to Google and use credit through OpenRouter instead of your own Anthropic credits on your own Anthropic account. It's really nice. Platforms like OpenRouter make all the sense in the world, and I would expect long term for these guys to win because Anthropic and Amazon and Google are too busy competing with each other to do this themselves. Do you know who doesn't care what cloud is behind their compute, though? Vercel. They don't give a shit where this compute is running because they're not competing in the GPU world. Vercel is not spinning up server farms with a bunch of GPUs in them. They don't care. So Vercel, and of course in this case OpenRouter, they don't have to worry about which place the traffic is routed to. They don't care as long as you get a response more reliably than you would otherwise with lower latency and higher throughput as well, which is really cool. Makes so much sense. So Vercel seems to have woken up to this reality and realized, oh, we could be that in between because Vercel doesn't care about where the model is being hosted. They're not a model host. It doesn't matter to them. They are effectively commoditizing the places where the GPUs run. The same way with AWS, you don't care which server warehouse your stuff is running on. You don't care if your CPU's Intel or AMD or whatever. The abstraction is a layer higher. This abstraction is a layer higher too. We also have somebody from OpenRouter hanging out here. While they do have some rate limits, but for 99.999% of their users, it's essentially zero. And that's the rate limit from Anthropic. But they can also route your traffic other places, so it barely matters. They don't have per user rate limits. Theoretically, if enough people are doing a ton of traffic on OpenRouter at the same time, they could hit rate limits with their providers, but it effectively never happens, and you're hooking into someone else's rate limit stuff. And even then, if you bring your own API key, you get around that too. So let's see what Vercel's up to here. Oh, yeah. Pretty much exact same thing as what OpenRouter is building. Generally speaking, if there's a company that's all in on a thing that is complex enough to have a lot of moving parts, and a company that's spinning up the equivalent on the side, I tend to think the team that's focused on it fully is going to win. You can look at something like Vercel Blob versus Upload Thing. Even though Vercel built Next.js and is like the lead of good TypeScript developer experience stuff, Upload Thing's a way better experience and has way happier users than Blob does. It's also more production ready, scales better. We built Upload Thing for a reason. It's because I wasn't happy with the solutions. Even though Vercel put out Blob around the same time, ours was better, we won. I think this is going to happen here too, where OpenRouter has a team of incredibly talented devs working super hard to make the best distributed experience for making inference happen. Vercel has it as a checkbox you can go hit in their UI and use it there. I don't see a world where their AI gateway beats out OpenRouter, but it could happen. I'm all for it. And having yet another way to circumvent the borderline extortion that is the Anthropic developer experience, trying to provision those models, I'm okay with you putting your money anywhere that isn't directly Anthropic at this point, because their platform is so rough to work with. So if you are using Claude models, please use OpenRouter or AI Gateway, or even just deploy on Bedrock or GCP directly. I don't care which you go with. Just know that the Anthropic experience trying to use those models via the API, it's going to bite you in the ass, and it's going to do it a lot. Yeah. I did actually miss a couple things, believe it or not, even after all of that. So let's just really quickly blast through those and wrap up. Rolling releases. This is awesome. Previously, if you wanted to spin up a new version of your app to a percentage of your users, you really couldn't. It was kind of an all or nothing thing. I ran into this a lot during the T3 chat beta, and we eventually just told users to go use the beta version to move traffic over by hand. It would have been really nice if I could have routed a percentage of our traffic to a different front end and back end. Not really realistic at the time. This is super useful for those of us who want to do big overhauls. Again, it feels like they're building a lot of these based on the pain points I've experienced. Also, that's a familiar profile picture. Dimitri's the guy who did the TypeScript Doom thing. Lunatic. Cool to see him popping up and stuff like this. Next, we have everyone's favorite topic, micro front ends. Micro front ends are proof that Vercel is now a big company, because they almost certainly need this for themselves. The concept of micro front ends is, instead of your components being files in a code base, think of them like packages. So a given component that is owned by a specific team can be updated, and you can update specific parts of the product without having to update the entire JS for everything. It means you can distribute everything from the framework choices to the build tools, pipelines, and all of that, so that your UI is broken up into the logical parts based on your teams. If you've ever heard the phrase, you ship your org chart, micro frontends makes it possible to ship your org chart. And since most businesses eventually need to go in that direction, it makes a ton of sense. We absolutely should have found a way to do micro frontends at Twitch. Instead, we ended up with a gigantic repo with a single package JSON that sucks to work in. This is the solution to maintaining good DX at scale, but someone has to pay the piper and deal with those shit DX experiences at that scale. Micro frontends means that a couple people have to maintain it and have a shit experience so that everybody else can do what they want to do. And if you do it right, it's awesome. Vercel seems to now be embracing it and allow you to split large apps into smaller, independently deployable units that each team can build, test, and deploy on. Awesome. If you care a lot about this stuff, you should probably check out Zephyr Cloud. These guys are the gods of micro frontends. I helped them with the copy on the homepage. I love these guys. They were an early sponsor. Still chat with them all the time. Good crew. They get it. Chat with them if you really want to make a scalable front end. And finally, Vercel Agents. I actually have no idea what this one is. Vercel Agent now in limited beta. It's an AI assistant built into the Vercel dashboard that analyzes your app performance and security data, focuses on observability, summarizing anomalies, identifying likely causes, and recommending specific action. Okay, so this looks at all of the data for your Vercel deployments and makes suggestions on things going on, from incidents to weird performance issues, and makes suggestions. Really cool. Nice to see. Excited to see where this ends up. It's in limited beta, so it's going to be a bit, but it seems really promising. That's really funny. I left the OpenRouter dashboard open, and now it has an application side error. Turns out writing code is hard. If only they had the Vercel agent to tell them what went wrong here. It was a very good day to be a Vercel customer, and I wish these things existed before. I'm very happy they do now. They're going to save me a bunch of time and money and a lot of frustrations going forward. And they might even save me some users if their captcha solution has fewer frustrating moments for those users. I am very excited about this. Let me know what you guys think. And until next time, peace, nerds.